All right, boys and girls, welcome back to the drive-through. We're going to do all these, I think. All right, number 7. This is certainly a Widmer-Ploy question. Right 2, down 8. Now, anytime I'm rotating, I think to myself, like, let me solve a simpler problem here, because I don't know exactly what to do. I have an idea. I think I'm going to, like, switch the order, maybe, and change the sign to negative, but think about this. What if I just had this one that was, like, 10, 0, okay? And I wanted to rotate that 270 degrees. Where would that go? It would go down here. And what is that new vector? What's the new vector there? Oh, love it. So, it looks like we have switched the order, right? And then made the second one the opposite sign. But the problem is, I don't know if 0 is neither positive nor negative. So I might have to switch the sign on that one too. But let's see what would happen if we went with negative 8, negative 2. Negative 8, I'll go back to black here. Well, I don't want to confuse you, or myself. Come on, ViewSonic, you can do it. You can do it. All right, so if I went left 8 and down 2, ooh, I think that does look like 270 to me. You know, because that looks like a right angle, which means that must be 270. So this one would be negative 8, negative 2. Okay? So I think if we rotate it 90, 10, 0 would become, what would that be? Zero, 10, right? So it looks like if we rotate it 90, we simply just flip the entries. So let's see if 6, 4 would go to 4, 6. Would 6, 4 and 4, 6? Nope, we're going to have to turn one of them into negative, I think, Carson. So let me see this. Let's go here. If I go 6, 4, and I want to go 90 degrees, then I think I'm going to go, I got to go to negative 4, 6. Oh, I do believe that is correct. Okay. So it's going to be negative 4, 6. Number 9. Reflected across the y-axis. All right, we can do that. So negative 9, negative 3 would become, well, the y-axis is the up-down. So what does that look like, you think? What does that look like it is? So what are the numbers? 9, negative 3. Excellent. So it looks like if we go across the y-axis, we just change the sign on the x. That makes sense. So what do you think we got to do to go across the x-axis? I agree. Change the sign on the y. Okay. Ooh, reflect 0, 16 along the line y equals negative x. This is going to be a Widmer-Ploy. Y equals negative x. Is that a positive slope or a negative slope? All right, so that's this one. All right? Okay, so we want to reflect 0, 16. Oops, sorry. All right, now let's see. When we reflect that across this line, I think, would it do this? Is that a reflection across that line? I'm not exactly sure the answer to this one, Carson. I should. If I put a mirror right along that black line, reflect it across that line, I think it's this. I do. Oh, yeah. Here's how I know that. Geometry. Equidistance theorem. This point exists right there. This point exists right there. Right there. There you go. So what is this new line right here, Carson? Or this new vector, I should say. I'm sorry. Now, flip that order. There you go. So then finally, number 12. This might be the messiest board in history here. Look at this thing. It's a work of art. 5 to, okay, the line y equals x. That's that line. 5, 2. Let's see. Looks like that. And so I think the reflection would have to be right there. You know, once again, if you use our equidistance theorem, this point is supposed to go directly there and be perpendicular, and that's supposed to be perpendicular. That was bad. Okay? So what do you think? I agree, Carson. Well done. Does that help? Can I get it?